So, the second part of this lesson is on the greatest common factor, the GCF. Greatest common factor is the biggest number that would go into both numbers. So, yesterday we practiced finding all of the prime factors by making a factor tree. And we're going to use those factor trees to find the greatest common factor for both. Yep, it's the same lesson, 4.3 yet. This is 4.3 yet. So the first thing you have to do is make a factor tree for both numbers. You'll be given two or more numbers, and you got to make a factor tree for the numbers that are given. Okay? Then you have to find the common factors, in other words, the factors that are in both numbers. So here's what I mean. The prime factors for 315 are 3, 5, 3, and 7. And the prime factors in 360, if you just look up here, you guys, are 2, 2, 3, 3, 5, and 2. Okay, those are the ones that are all the prime factors for this. These are the prime factors for 315. Now, what we have to do with those is circle the ones that are in both. So there's a 1, 3 in both. So I circled 1, 3 in each of the trees. Then I circled 1, 5 in each of the trees because there's a 5 in both. And there's also another 3 in both. You circle the ones that are in both. I didn't circle the 7 in 315. Why not? Why wouldn't I have circled the 7? Effie?
Because there isn't a 7 in 360.
Right, there's not a 7 in 360, so don't circle the 7. I didn't circle any of the 2s. Why not?
Because it's not common in both?
Yeah, because there's no 2s in this one. Okay? Only circle the ones that are in both, and then take one set of the ones that you circled, and multiply them together. And that gives you the greatest common factor.
Cool.
In other words, this makes 45, and this makes 45. 3 times 3 times 5 is 45. 3 times 3 times 5 is 45. So 45 goes into both of these numbers, and it's the greatest common factor.
That's simpler than drawing them all out.
Yes. Yep, then listing all the factors of each one, that would take a long time. This is a much easier way. Yes?
So for the answer thing, so we just have to do that, so like 3 squared, and then just times 5, and then we get to do this.
Yes. Yep. But listen, the same is true. Wait, you guys, wait. The same is true if you had variables. So look at this one. This one isn't a number. This one is a variable expression. X squared times y and x times y squared. So let's say that these are your two numbers. This is how you factor numbers with variables. You just write it out in expanded form. So x times y, right? And this is x times y. So you write it out in expanded form, and then you just, again, circle the common factors. So there's an x in each one. So the GCF has an x in it, and there's one y in each one. So that's in it. And that is your greatest common factor. There's not another x in this one, and there's not another y in this one. And so you use the ones that are circled. Okay? Now, what I want you to do then is practice this. Do numbers 30 through 41 for tomorrow. On page 193, 30 to 41. Okay? You may go.
30 to 41.